On the Electric Dreams project, we can determine or see what branches currently exist. So I have the cloned folder on my desktop. I've navigated into that folder so we can see here that I am in the Electric Dream folder. And now if I just say get branch, it's going to tell me the branches that exist within this project currently. So looking at this, what I first want to do is just go out with the populate vars step 1, because this sets us up to have some discussion about the details that are in it. So anytime you say get branch, it will show you the available branches in your project, which is a handy way if you don't know the name of the branch. Now I can just check out step 1 populate vars. And now I switched into that branch. Now, clicking over to Sublime, we'll see that the document already updated itself. I didn't refresh, I didn't change, I had index open, I go here, boom, it's updated. Now with this, the HTML, the markup is what it is. We've got a headline, we've got a paragraph, an input, and a button. Nothing spectacular, nothing extra fancy, just basic stuff. You can decide to update this and change it. Just know that we have, the paragraph has an ID of computer. We will need that because this is the paragraph where we will be updating the text where the computer talks to us. The input has the ID of human, and that is where the player or the human gets to provide their input for this kind of artificial intelligence experiment. And then the button doesn't have an ID on it because there's only one button on the page, so we can just grab that element, and we can grab that element by its tag name, because if we don't have a class or an ID on something, we can actually still access them through JavaScript and not using query selector, but we can actually grab them using a different method. So right now, I'm going to challenge you to find 2 other methods for accessing things besides query selector. So a human has an ID on it. So how do we gain control of something through JavaScript when it has an ID on it? And if we want to grab something by its tag name instead of an ID, how do we go about that? Looking up answers, either write out JavaScript or type JS and get, as soon as I do that, let's see, get element by ID. Now what comes up? We have W3 schools, get element by ID method. Okay, let's try that and see what that looks like. So document, get element by ID. We have the ID name inside quotation marks. So we see the example of it here when we scroll down. So document get element by ID, my header. We can see that we have this header down here. So then we will be able to have access to that. ID is my header. Notice when we're saying get element by ID, we don't put the pound sign or the hashtag in front of it. That is a difference there. So going back into here, if we compare that to query selector, because it doesn't know whether we're querying something by a class, an ID, or a tag, we need that hashtag or pound sign to do that. So human is equal to document dot get element by ID, and then I can now specify, and this is an instance where I could use single or double quotes. Both are fine, and it will work. So I can go back and look. Oh, that's no wonder it looked funny. It's a lowercase d. Hey, and now in Sublime it turned magic blue. Tells me then it's not unhappy with it. So get element by ID. So now I want to somehow gain access to something by its tag name. So I want to change my query. Now, W3 Schools is a great place to look for just real conventional, plain, ordinary, old school stuff. One of those, get an element by ID. So now get in an element by tag. Let's see, we're right back at W3 Schools. Now, a few things about this is, if you remember on get, it was get element by ID, because there's always, in ID, there should only be one of that element on your page. But we can have multiple elements of something, and what it does is it returns a list of those elements in an array, and we specify which one. So if I had, in the case of the project we're working on, if I had a couple buttons, the first button would return as element 0, so I would put a 0 in here. If I had 2 buttons, if I put a 1, this would give me the second one in my markup. That's what the bracket notation is referencing here. So just copy that, click over here, but change it from UL. Now in this case I want to say button. So the 0 says I am getting the first button in my list of buttons that have been returned. So if I had a couple buttons, this would return all of them, but then this one says I only want the first one in that list, 0. Then this would be a 1, 2, 3, 4, 5. So that's the syntax at work there. The key thing to keep in mind anytime we're doing this is that when we're grabbing an element, it's single, but when we're grabbing things by tag name, it's plural, even if there's only one on our page. That's a very common typo to make, as you type it in and you're like, get elements by ID, and then your code errors out. You're like, what's going on? Why am I upset? I get error messages in my console. JavaScript hates me. I'm going to go cry in the corner. Yeah, it's just an S. How do I make my input field the focus after the page loads? Because human, which we want to become our focus point, is already in memory. We've made var human equals document get element by ID human. We can then say human dot. Now if we look at what's being returned, adding focus to something, we look at the focus method. We can do the whole thing, but if it's already in focus, we can just dispense with that and just say what the element is and just say human dot focus. Because that's assuming we haven't already tried to put it in memory. Look here and boom, it's blue. All is right with the universe. So now that we have the core essence done, we're going to add some functions into this. It's on the next branch. The next branch has a bunch of stuff that you can try to build and not peek ahead as you think through the process of what needs to happen, where we need a couple functions here where we need event listeners, so we're listening for keyboard input so we can find out if they hit enter. We're listening for the button to be clicked on, so we're listening for that mouse event. So the same things we had in the previous project we're incorporating here. When you hit enter or when you click with the mouse on the button, it's firing off a function called play game. Play game will then analyze what the user has said, and then it will generate the appropriate response. And then there's some additional elements that can factor into that. So I'm going to switch to the next branch on it, which has most of that stubbed out here. Oh, hang on. Because I'm trying to switch and it's unhappy with what I've done because I made a bunch of changes to this. So it's going, oh, this is different than what's on there, so you need to commit your changes or do something. So I do just need to add and commit quickly. So just remembering I can do git add all, git commit. And then now I can switch my branch. Now switching the branch, there's a few more things that are going to show up here. And on this branch, there's some other variables that we're going to use as part of this project. So the way it's going to work is I click on a button, it calls play game. I press a key. If it registers that key as enter, it calls play game. I have 4 versions of play game worked out down here, and we'll take a look through those and start to understand how those come together in just a little bit. But for now, it gives us a starting point. A few other variables that we're going to need, because we are going to have a number of responses to choose from. Within these responses, they're being put into an array. So in our other programming, we've used arrays, which is just a collection or group of similar type objects. In this case, it's a bunch of short sentences or strings. So we have an array of strings. Array notation is always done with the square brackets. So the square brackets say it's an array. I put extra returns in there because I think it makes it more readable than looking at it like this, which that's okay to have it like this when it's a short array. But as we work on the project and develop it, I'm hoping that your list of responses not only will be longer than these 3-word phrases or 4-word phrases, but also you will have many more than 3. And when you do that, if this stretches way out, it gets hard to read. And it makes it easier to read it if you look at it where it's now on separate lines like this. So that we've separated out and we have each element on a line. Just we have to remember, don't put a comma after the last element in the array. But we have commas between each element. So if we do it this way, it just makes it easier to see what is going on. So that's where we store the messages the player will hear. We're going to take one of these and we will put it inside computer message and give that message back. The human message is going to hold the value that the user is providing. So when someone types into the input form, it will hold that value. And we saw during the demo where it would sometimes give the same answer twice in a row. So what we need to keep track of is, well, what is our current response that we just had? And what's the new response? And we need to keep generating new responses until the new response does not match the old response. And once we know that, then we can move on and have a message to give back to the player. So it's a way of trying to figure out that we keep taking what our current response is. So if it was good for you, we generate a new random number, 0, 1, or 2. 0, 1, or 2. So currently, if good for you was our answer, our response number would be 0. Then we generate a new number, and if that number is 0, we try again. Oh, we got another 0. Oh, we got another. Oh, we got a 1. Okay, now the new message will be you are a loser, so it doesn't repeat the message back twice in a row. So that's going to be how we're going to work on solving that. This is just one solution. If you come up with a different solution, I would love to see it. So there's the rest of our variables, our event listeners, the functions they call, and then finally play game. Now play game, just going to uncomment some things so we can see. So our order of business is we need to determine a random response, and then we need to update the text in the computer's message field to that new response. So that's what we need to have happen. So the goal is to figure out how do we go about doing that. So I'm going to comment these out before I break my code and then wonder why it's not working. So step 1, we need to figure out a random response. Now that response number, and version 1 doesn't check to see if it was if we used the answer previously. It just grabs off that list of things. Version 2 is going to do that. The way that we get a random number is we use math.random. That gives us a random number between 0 and 1 up to but not including 1. So if you think about all of the random number generators that you hear about when we're doing coding, it's always giving us a value 0 up to, but not including 1. So we take that random number, multiply it by the number of items inside my generic responses. In this case, it would be generic responses. There are 3 of these here. Oh, let's see, that needs to be commented out too. Otherwise that'll break. All right, so there are 3 responses. So now what floor does is my random number is 0 to 1, times it by 3. So that means I'm getting a number either between 0 and almost 3, but then we round it down. So 2.99999 rounds down to 2. 1.999 rounds down to 1. Anything less than 1 rounds down to 0. So that gives me 3 numbers, 0, 1, or 2. So that means this statement here will give me a rounded down floor of a random number, of which that random number is going to be somewhere between 0 and 2.9999999, about 16 decimals long or so. The next line that we need is we set our computer message equal to that number, which will be in this case 0, 1, or 2, and we grab the element out of the array. So we use the array notation, knowing that generic responses is an array. We're able to grab it by saying square bracket 0, square bracket 1, or square bracket 2 to grab that element based on its position in the array. So when we built the drop game, or the catcher game in Intro to Programming, we used arrays. We had a whole bunch of objects, and we were able to access each object in that array. You had the 1,000 object homework, each object in that array. We used the square bracket notation. This is now square bracket notation, so I'm grabbing it based on a number. And then the final thing we do is we set the inner HTML, or the text of the computer paragraph, equal to this text, which is then going to be one of these 3 statements. So if I run it, and it really matters not what I type, and then we can see that the computer is being less than friendly right now. Now version 2 uses both a new response and then response number. So it generates a new response number. It says, okay, well, let's come up with a new number. Looks similar to what we had before. And then it says, well, new response is equal to my response number. Well, if there is no response number, then response number is equal to the new response. Otherwise, it's going to keep running this line of code to keep resetting new response. Now, if you remember in Intro to Programming, I said I never use while loops. I only use for loops. In here, I wrote a while loop because this is an opportunity to do that. For loops work really well when you know how many items you're trying to work with. So when we built our catcher game and we had X number of falling drops, we knew how many there were. If we did a 1,000 object project, we knew how many there were. A for loop is perfect for that. When we don't know how long we're going to keep doing something, a while loop works really well unless you create an infinite loop, and then that'd be bad. In this case, it's unlikely to do that because it just has to get a random number not equal to the previous random number, and when we only have 3 choices, it should go pretty quick. Even if we had more choices, it would still go pretty quick. More choices would be even quicker, I suppose. So we just say while they're the same, keep making a new response until they're no longer the same. And then we set new response equal to, or response equal to that new response. And then the next 2 lines are the same as version 1. These are the same as version 1. So these lines of code are just simply replacing this line of code here. And now, if we run it, we'll see that it will never give the same answer twice in a row. But with only 3 answers, it becomes pretty obvious that there are only 3 answers. And it's no longer asking questions. That's one of the key things that we will want to work for is at times we will want to ask a question, and at times you will want to ask or provide a response. When you're asking a question, you need to think carefully about what question you ask and what would common answers be. Because when you do that, that allows you to then start to structure it so that it's actually going to appear to be an intelligent machine. So version 2 isn't terribly exciting. It's just using a while loop, that thing I said I never use. So apparently I'm a liar, but oh well. Now, version 3 gets a little bit more interesting because in version 3, every time it grabs a response, it removes that response from the array until there's no more answers. And when there's no more answers, then it gets really snarky with us and does some other mischief that we'll see in a moment. So it's using an additional array method. So arrays have different methods that they can do. And one of those methods is splice. And what splice does is it removes an element from an array. So it takes that piece and gets rid of it. It cuts it out. We're splicing it out of that array. And we'll talk more about that syntax at a future session. But if I look at this, I can, how am I today? It doesn't matter what I say. Good for you. Now, I only have 2 more choices of you're a loser or I like you. Okay, I like you. Now there's only one more possible answer it can give me. You're a loser. And now, the next answer it can give me, if we look at this, well, we can see. I'm done talking to you. You may leave now. And then not only can I leave, it kicked me off and put me onto a new web page. Now, in this case, it was kind enough. It left the back button still active. It's actually possible. So I used the timer method of set timeout, and then it calls a function after 2 seconds, 2,000 milliseconds. And it calls this function, and it uses a sign, which leaves the back button working. But if I chose replace, now, when I go to that next page, 1, 2, 3, 4. And if you look up here, there is no back button. It didn't open a new tab. So if you want to be really unkind to people, you can change essentially the contents of a current element in the browser history with something else and eliminate the back button so they can't ever even go back to that page. So apparently this computer really did hate us tonight. So the final part that we're going to on this, because just randomly doing messages is fine and good, but it gets kind of lame after a little bit. It's much more interesting if we take the message that the player has input and analyze it. Now, if we remember, the opening question is, hi, how are you? 2 common answers that people would provide would be good or bad. Now, you could think up more answers and further break this out. So the more detailed you get, the better it's going to be. Right now, I just have good, bad, and if it's not one of those 2, then it gets snarky and says, you know nothing. I'm like, okay, well, that's not very nice. But if we pull it up, okay, how are you today? So if I say good, okay, we can see how it responded to it. If I say bad, if I say go away, so we can see how it's now responding to these 3 possible inputs. So it's analyzing what I've said for that particular word or phrase. Now, instead of just setting the computer message equal to this, you could now ask another question. And then that would give you further opportunity to look on an answer. So if they say good, instead of saying that is good for you, we could say, what is your favorite color? And now else if human message. And now what we're using is the index of method. And what that does is it looks on a string or on a word or a sentence, looks across the letters and says, does this exist? And if it does, it returns a number and says, yep, it does. So if my message or response was, say, red, so if we say that red does not return -1, if you use index of and it analyzes your string, if it doesn't find it, it gives you a value of -1, meaning it's not there. But if it gives you anything other than -1, that means it found it. So if we say the index of red is not equal to -1, we don't care where it is. We could say, because we could say, what's your favorite color? And they could respond and say, my favorite color is red. Most people are lazy and would just type red. But someone may be one of those used to, oh, I should use sentences. So my favorite color is red. Well, give me the same result as red because all we're looking is, did it exist in that query? And if it did, then we're good to go. Got to get rid of this extra curly there. And now I can say computer message is equal to I like red too. And then ideally you would ask another question. So if you have a series of questions, the more questions you have, the more answers you're looking for. Now what we're doing here is not the most organized way of doing this, but it allows us to not have to have an array of answers, an array of questions, and then be grabbing and trying to figure out how to key. So this answer goes with this question, this answer goes with that question. If we just keep it tied up with this if-else-if statement, it's not the prettiest way of solving this, but I think it's the least complex. I mean, it's truly not the prettiest way of doing it. But if we do this and now run it again, so now if I say good, it says, what is your favorite color? And now if I said blue, well, that's not working. But now if I said red, it's like, I like red too, but if you asked another question. So if you are clever about how you think up questions, how you think up further answers, you could make a pretty smart computer. And instead, down here, instead of nothing, now at the very end, we could even just go and grab I'll grab that stuff. So then we grab, new response, blah, blah, blah. And then, and then we need response. Oh, I'm missing one more line. And this one. Got that line there. Whoa. Hi. Favorite color also have will be right. Oh, I wiped some stuff out here accidentally. Whoops. Needed to paste it up here. Oh, I got rid of too many. Here we go. There we go. So now it's going to choose one of those random generic responses if we entered in something else. So now if I blah, 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 it gives me that. If I say good, rad. So depending on how you structure it, you're going to be able to come up with a smart computer. But you need to think through answers. So if you ask a question, what are all of the common answers? From those answers, what further questions could you ask to make this computer start to have personality? And at any point in the game, you decide that you just want the computer to become self-aware, sentient, and just obnoxious, or pleasant and happy, and to stop asking questions, you certainly can do that too. But it should go through a series of things. So your homework this week is to then work through and figure out how to start, what are questions and what are answers. Whether you put it into code or you put it, you start writing those out, but you start mapping it. But think in terms of sequence, so that if they answer your first question, what are the answers? And then what are the follow-up questions you will ask at that point? And then what are, based on the follow-up question, what are the common answers that someone would provide? And try and get 3 or 4 layers deep. Or if you like the movie Inception, go 7 layers deep.